Oh yeah, these are totally like Jolly Rancher flavors.
Okay, so today is April 15th, and
Somewhere, Cindy flavor.
the slopes from your homework were all different steepnesses, and that steepness of a line, that's a good word Peyton threw out there. The steepness of the line is denoted by a number we call slope in algebra. That makes sense. Slope is slope. You know what a slope is. In American textbooks, American curriculum, lots of places, it's known as slope, but it seems like in some of the Asian languages and materials, it's known as gradient. So when you are winding down this evening and you pull out your math textbook for a little light reading before bedtime, when they say gradient, it's the same as slope, all right? And actually engineers in that use this word gradient a lot too, but you should know they're interchangeable. Slope is really nothing more than a ratio. And we studied ratios this semester. They'll be on your exam. What did we say that a ratio is? White box. Oh, that's Peyton. I'm sorry.
Peyton's got this.
Sorry.
A comparison between two numbers.
That's right, Peyton. That's a comparison. Comparison between two numbers. Nice. All right. So the slope compares two numbers. It compares the vertical rise to the horizontal run of a line. So we can say that the slope is the ratio of the vertical rise of a line to the horizontal run.
Maybe the exam should just be all ratios.
We throw in rise and run because that usually helps students differentiate vertical up and down, horizontal back and forth across the ground. All right. Now there's some other symbols and whatnot that we use for these. We always use the variable m, the letter m, to represent slope. And instead of saying the vertical rise, that's the y direction on the graph. So we can say it's the change in y over the horizontal direction is always the x. So we can say the change in y over change in x. If you recall last year, I occasionally use the triangle to mean change. And I believe Mr. Anderson uses it a little bit too. It's a symbol that means change. Okay. So this is another way of saying the same thing. Slope equals change in y over change in x. Also, sometimes students know it as a rise. They call it the rise over the run. Just kind of catchy to say slope is rise over run. Now, one of the biggest mistakes we want to prevent is you mixing up the y's and the x's, right? Then it's not slope and you get everything wrong. So there's one cute other little saying we offer you in case it helps you remember, and that is, be wise.
Don't confuse y's.
Put your y's on top.
That doesn't rhyme very well.
Y's and y's is the clever part of it. Y's go on top, all right? Y's come first. So that's slope in a nutshell, all right? Let us move on. Any questions?
Don't rise because you got a 0. Be wise and put your y's on top. And don't flop.
All right, here we go. I have two functions here. Y equals 2x minus 3. And y equals negative 2x minus 3. Let's get a picture of these on the graph, all right? So in order to do that, we need to come up with, let's say, 3 solutions to each one of these. You need the graph though, so take a second and sketch in your notebook just a simple coordinate axis with hash marks, no numbers. So quickly sketch that in your notebook. Okay, so students came up with 3 pairs of ordered pairs for the green function that are solutions. We plotted them and drew in the lines. And now we need to do the same thing for the blue function, and then we're going to look at how the slopes of these lines are different. Okay? Okay, so how would you say the slope of these lines steepness of them compare? How would you say the slope of the blue line compares to the slope of the green line? In relation to each other.
I don't.
Really?
Are they the same?
They are the same. The steepness of them
Oh, yeah.
is the same. What's different about them? What's different? Elsie?
They're going in different directions.
They're going in different directions. This green one is going up in this direction, and the blue one is going down in this direction, or pointing to the left, you could say. So now what part, when you look at the actual equations over here, the functions, what part of the equation might tell you that? That they have the same steepness but in opposite directions. Looking at these equations here. What connection might you make there? Katie?
Green one, positive, like positive.
Okay, but and where are you seeing that in the equation actually? Just stop rattling your rulers. Nobody sees a connection? Slopes are the same but opposite. Where does that show up actually in these equations, Ellie?
They have the same exact properties.
What part of the problem? Well, okay, yeah, everything's the same except the sign of this coefficient right here, yeah. So that is where we get information about the slope in the equation or the function. All right, one's positive, one's negative, but they have the same steepness. Now, we're not going to spend time on this today, but it's showing so clearly here. What do these two equations have in common, besides the steepness being the same? What's the other thing they have in common? Let me look at the graph. Krataska? Yeah, they're both crossing the y-axis at 0, -3. Can you see any connection to the equations and that? The idea that it's crossing at -3, Lauren?
They both have -3.
Yeah, these constants on the end, both of these numbers are -3, and that's where it's crossing the y-axis. That we're going to come put together with it all, and this constant tells you where it's crossing the y-axis, so it'll be really quick and easy to graph these eventually without the points. All right, let's see if you're paying attention about this slope, and move to this screen. You don't need to copy the graph, but just copy the words here. Slope can be read like the words on a page. In English. Not yours.
What about Mandarin?
Slope can be read like the words on a page from blank to blank.
Can I write it up there?
Shri, how do you read words on a page from
Left to right.
left to right? Very good. So if we're talking about looking at a line and deciding if it's got a positive or negative slope, we can look at it as it travels across the page from left to right and ask ourselves if that particular line is going up. And if it goes up, it's got a positive slope. That makes sense, up is positive. And if it goes down, it's got a negative slope. So, let's talk about this with respect to the blue line. If I'm standing here or looking at the blue line and start at the left of the line, like I do the words on a page, and look at it as I go to the right, is this sloping up or sloping down? Angela? So I would say it has what kind of slope? Negative slope. Here we go. So this has a negative slope. Does anyone not see how I say it's going down? Which one of the lines has a positive slope? Which one of the lines has a positive slope? How about Jack? Left line. As I stand here and look at it from the left, as I go to the right, it's going up, way up. So it has a positive slope. What's another line with a negative slope? Negative, Aaron?
Green.
Green. Green is going down, it's negative. And that leaves red, and it is positive because it's going up. You got to do some of that on your homework. Any questions about that?
No.
Okay, now the next big idea is that we can take 2 points on a line and use them to figure out the slope, the steepness of the line. So that's what we're going to do here. I need you to sketch these graphs kind of in a similar way that you just sketched that other one on a new set of course cards. Don't number them, just do the hash marks and put the points on them. All right. I'm going to pause this.
Who's gone today? In this class or in school?
Okay, we're going to look at this graph first, and we are going to use points on the line. And here I've given you 2 clear points that you can use. You can use any 2 points, but these ones are real nice. They cut at integer ordered pairs. Slope, m, is the change in y over the change in x. So we start at a point on the line, and we look at how much it changes in the y direction to get to the other points. My other point's way up there, right? So my y change, I gotta go up, 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 up to here. That's my change in the y direction. How many units is that? I'll come here and count. Hold on. 10. In the positive direction, we move up 10. My change in the x direction, I start here and I gotta go over, over, over to here. That's my change in the x direction. How many units is that? Right? 5. 1, 2, 3, 4, 5. So my slope, the steepness of this line is the ratio of 10 to 5, which simplifies, Sophia, to just 2. So the slope of this line is 2. It's similar to the one on the last screen. It's just it's got a different y-intercept. Okay? Looking at this one, what would you say about the slope of it? Is it positive or negative? Melky? Negative. It's negative. So when you do this, and we are really short on time, I just want to say you got to go from one point down. Down your change in y is 4 units in this case, so it's negative. And then over, and it happens to be 8 units. So you can see how the negative slope shows up in your calculation. Okay, we rushed that because we ran short on time in this class, but that's it.